Graphing vertex form. The vertex form of a quadratic, the general form, is y equals a times the quantity x minus h squared plus k. So here's a specific example. 2x minus 3 squared plus 4. The A does a vertical stretch or shrink. So the A there's the parent function for the quadratic. This is y equals x squared, where a is 1, h is 0, k is 0. And we'll talk more about h and k in a minute. But the vertical stretch, if we have a 2, that makes it open faster. We have, say, a 4, it opens faster. We have a number less than 1, like this, that would be 1/2. Now, the H is a horizontal translation. So the H looks like this. Here's our parent function. Parent function is x squared. Now, the H moves the vertex, which is right here, left or right. So if we move, let's say we have x minus 3, that moves the vertex over 3 to the right 3. If we have x plus 5, that moves the vertex on the x over 5 to the left, negative 5. And if we have a k, that's a vertical shift, or a vertical translation. And an example of that, here's the parent function. The parent function is x squared. If we have x plus 0 squared, we're not going to move the h, we're going to leave it on the vertex on the x unmoved. We're going to move the vertex up. So we're only going to change the k, so that would move this up like this. Now if we have x plus 0 squared minus 4, that would move it, the vertex down. So that point right there would now be negative 4. So all the shifts are going to be in reference to the parent function. The parent function is y equals x squared. And the parent function looks like that. Where the vertex, which is, there's the vertex is at 0, 0. And it opens up. And this is called a parabola. The parabola opens up. So here's some examples. We have y equals x minus 3 squared plus 4. So the x moves right 3. This right here, we're always going to move opposite that sign. So we're going to move the vertex over 3 and up 4. So it looks like that. We have y equals x plus 2 quantity squared minus 5. We're going to move the vertex left 2 and down 5. So that's going to be negative 2, negative 5, and it looks like that. We have y equals negative x plus 3 squared minus 7. That moves left 3. That's positive, so we're going to move the opposite direction. Left 3, down 7. So this point right here is negative 3, negative 7. This negative in front of the parenthesis has the parabola opening down. So y equals 2x minus 4 squared plus 3. So the vertex is going to move right 4, and here's why that happens. You take that x minus 4, set that equal to 0. You're setting that equal to 0 because y is 0 all along this x-axis. So this 0 here, we're letting y be 0. Add 4, so x equals 4. That's the math to why we move opposite. So x equals 4. Plus 3, so we move up 3, right there. So there's our vertex. Our vertex is at x equals 4, y equals 3. Now, that line that we put through there, the line of symmetry, that's the same as the standard form. Through the x-axis, that's the line of symmetry. Now we find one point on each side of the x-axis, that line of symmetry axis. So our vertex is at 4, 3. So we're going to find a point at 3 and a point at 5. So I substitute the 3 into my original equation here. Negative 1 squared is positive 1. 2 times 1 is 2. So when x is 3, y is 5. Because these 2 points are equal distance from the vertex, we don't have to calculate this second point. It's at the same level as the 3. So if I go 3, it's 3, 5. There's that point. 3, 5. And 5, 5. And it opens like that. Okay, one last one. Y equals negative 1/2 x plus 2 squared minus 3. So the vertex is at negative 2 from this, right there, negative 3 from there. negative 3. I know it's going to open down because of that negative in front of the 1/2. So we're going to have an xy. Our vertex is at negative 2, negative 3. Here's our vertex. Now, I'm going to choose numbers that are divisible by 2. So if I use negative 4 and 0. See, negative 4 is 2 units from negative 2, which is the vertex, and 0 is 2 units from negative 2, which is the x vertex. Okay. That's our line of symmetry. Now, I do the substitution. I have negative 1/2. X, I can either put negative 4 or 0 in. I'm going to put negative 4. So 1/2. Negative 4 plus 2 is negative 2 squared. Negative 1/2. Negative 2 squared is positive 4. Negative 1/2 times 4 is negative 2, half of 4, minus 3, which is negative 5. Because 0 is the same distance from negative 2 as negative 4 was from negative 2, that number is the same. So, at 0, x is negative 5, and at negative 4, x is negative 5. So there's our parabola, opening down. And that's negative 4, negative 5, 0, negative 5. So there's graphing using the vertex form.